Hello, everyone. Welcome to today's session. We're going to be getting started in just a couple of minutes. Just giving a moment for everyone to get logged in. Thank you so much for being here today. While everybody gets logged in, I have a couple of upcoming webinars I'd love to tell you all about. On Wednesday, September 18th, we'll be having a presentation on engaging frontline workers to solve ergonomic problems, and that will be with Dr. Devana Pilschuk, also with the University of Cincinnati. So this month, we're so glad to have two speakers from the University of Cincinnati. Thank you for being here. On Wednesday, October 16th, we'll have a webinar on control of localized fatigue with Dr. Thomas Armstrong and the University of Michigan Center for Occupational Health and Safety Engineering. You can learn more about these upcoming events and register for webinars on our website. I'm going to go ahead and pop the link in the chat for anyone who's interested in seeing other upcoming talks. And without further ado, it's my pleasure to welcome you to today's webinar. On behalf of education and research centers throughout the country, we are pleased to present the Industrial Hygiene webinar series. This is a collaborative effort on behalf of each education and research center's continuing education program and aspires to provide access to current research supported through NIOSH ERC programs. Thank you all so much for being here today. We really appreciate you joining us. Today's webinar, Artificial Intelligence to Enhance Occupational Exposure Assessment and Control, is presented by Dr. Jun Wang in partnership with the University of Cincinnati. Few housekeeping items. You are going to be muted during this presentation. So if you have any questions, you can enter it into the chat. Or, if you have questions for the presenter, you can go ahead and put them in the Q&A box. And we'll save time at the end of the presentation to address as many questions as possible. We'll also have that chat open, so you feel free to chat amongst each other and join in the conversation. However, if you have panelist questions for Q&A, please do put them in the Q&A. That just helps me keep better track of them when the time comes. This presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. And all participants who log in with their registration email for the full live presentation today will receive an email tomorrow with a link to an evaluation form that will qualify you for a certificate of completion with 1 continuing education contact hour. Once the evaluation is completed, you will be able to access and print your certificate. And it's my pleasure to welcome our presenter today, Dr. Jun Wang, PhD, PE, CIH, CSP, and CHMM. Dr. Wang is an associate professor in the Division of Environmental and Industrial Hygiene at the College of Medicine, University of Cincinnati. He also serves as the graduate program director for environmental and industrial hygiene and directs both the industrial hygiene and outreach programs at the University of Cincinnati NIOSH Education and Research Center. Dr. Wang earned his PhD in environmental engineering sciences from the University of Florida. His research interests span a broad range of topics, including workplace inhalation exposure assessment, engineering controls and personal protection against aerosols, pulmonary toxicology of hazardous air pollutants, and interdisciplinary approaches to addressing workplace health issues. Thank you so much for joining us today, Dr. Wang. We're looking forward to your presentation.
All right, thank you, Michelle, for the introduction. Yes, I'm glad to be here, and I appreciate this opportunity to present some of my thoughts on this very hot topic, AI or artificial intelligence. So before I start, let's see. Here's the outline of the talk I'm going to present today, and it's going to have 42 slides. So I want to say this ahead of time to make sure that it's not a super long talk, and I hope we can have some interactions or discussions at the end. So because this is an ongoing, evolving, emerging technology. So definitely I'm not gonna go over everything about AI today, and especially not going to go too much details about how to implement AI. Rather, this is a talk about the overview of AI and how does it change occupational exposure assessment and control. So my presentation will start with the basic of AI, and everyone probably already heard these words before many times, and how it can be applied in different scenarios in occupational exposure assessment control with some examples and some principles. And a very important topic at the end, it's the ethics about AI in occupational environment or workplace implementation. And I'll end with some takeaway messages. So everyone's here because you heard about AI or you're genuinely interested about AI as I do. But it's really not something new. So the word of AI or artificial intelligence was invented or established by computer scientist John McCarthy from Stanford at the time of 1956. So he kind of want to define a term that differentiates something at the time is very hot topics called cybernetics. So he says the science and engineering of making intelligent machines should be defined as artificial intelligence. In fact, almost all the components I will talk about today, including machine learning, chatterbot, and deep learnings, are all established around 1950s and 1960s. Amazing, right? It's about 50 years ago. So really, there's nothing new about AI, but what changed? So what made them become a hot topic right now? I would say it's mostly because the computational power these days that and as well as the large amount of data available over internet or over any database. So the computational power introduced by stuff like CUDA and other parallel computing capacities really boost the AI application. So AI is not new, as I said in the previous slides. And in fact, if you have watched, if you follow the Apple event yesterday, and well, I guess not a lot of people are excited about the adding a color to a new iPhone or something, but a lot of people are interested in the so-called Apple Intelligence or AI from their offering. So that is the thing, which is AI is not new, and especially narrow AI or AI that specializes in a very specific task has existing for a long time. So narrow AI can do stuff like voice recognition, stuff like Hey Siri or Hey Alexa, and also can do some limited amount of like car driving or those sort of things. So they behave like human. However, they don't necessarily think as a human. So narrow AI has been performed very well on single task, and it has limited adaptability because it's kind of struggle to adapt to situation that's outside their program parameters. Here are pictures here. I'll try to use my pointer. Yeah, here are some like examples of the narrow AI applications. But what we are going to talk about today is the general AI, where or AI that's capable of performing any intellectual task that a human can do. So basically, replace our human brain. Here's kind of like how does human functions in a scenario. So we have human brains and we have sensors and we receiving data from sensors. When I say sensors, not any like instrument, but our eyes, our ears, and our hands. We receive environmental data from those sensors, and our brain kind of process those data and compare that with the knowledge we have. Then we reach a conclusion and perform action based on that. So general AI is designed to replace this center part, human brain, to have human-ish intelligence. It tends to try to mimic human level intelligence, allow it to understand stuff like complex concepts, reasonings, and learn from experience and adapt to new situations. It does require complex multi-domain knowledge. So in the past, when we talk about AI or general AI, it's considered as a theoretical concept because the technology has yet to reach to a level to create a truly general intelligence system. But now it's the time, and definitely looking forward to a lot of adaptability of those AI systems in scenarios like what we're going to talk about today. So a lot of people ask this question. So what exactly is AI? Well, what's the AI differences between AI and the machine learning? So I would say in my perspective, AI at this point is about 95% machine learning. So machine learning is using algorithm to teach computer to perform tasks with and without instruction. So we know those are supervised learning and unsupervised learning. typically we ask machine learning algorithms to process large amount of data to identify patterns and predict outcomes. And for example, like the picture here shows a TikTok app, and like my daughters really like them, and social media using machine learning to predict whether what kind of video you like to watch or what kind of stories you like to read. And of course, there's a plateau of problems come with that. And inside machine learning, there's this thing called neural network, because we talk about how machine learnings are designed to mimic how human brain functions. And how does human brain functions? It has this kind of a nodes or specific units called neurons. So neural network, it's a computer terminology that using layers of computational nodes to mimic how brain works. And within neural networks, there's deep learning, which is a subset of a neural network or a subset of machine learning that build based on neural network process analyzing data. The differences between I guess machine learning and the specifically deep learning is that deep learning is usually used for very complex tasks like natural language processing and object detection, imaging recognition, those sort of things, which we'll talk about today later. And that comes back to the question, is AI basically machine learning? So without a specific definition, AI can be anything. So without specific definition, AI can be just as broad as computer program. Any computer program can be seen as AI. However, one issue is to define is what does intelligence is. Without this different definition of intelligence, one will make a mistake to name a regular algorithm such as ML, DL, or a neural network as AI. So to answer this question, we need a kind of a look at some of the words we have used before, like data science 2.0 and the industry 4.0. Those things has been mentioned a lot in the last decade. Data science 2.0, it's a something beyond the regular statistic analysis, while industrial 4.0, it's what we call the fourth industrial revolution. That's basically implement AI in every sectors of industry. So there's since machine learning is about 95% of the AI right now, we can talk about a specific types of a machine learning. So there's a supervised learning that it will feed into labeled and structural data, and it will kind of like there's some sort of level of supervision to the machine, and it's more similar to the traditional statistic analysis. Those models of supervised learning, including stuff like linear regressions, logistic regressions, decision trees, and random forest models. So it's pretty good at predicting stuff like safety and failure of the certain process, and try to find the disease risk factors. It's supervised learning requires human or users to help the machine learn, while unsupervised learning that's typically don't use labeled training sets and data. Instead, the machine itself will look for some patterns that are less obvious in the data. So unsupervised machine learning is very helpful when we need to identify patterns and making decisions that doesn't necessarily have the best label data. So those algorithms are like unsupervised learnings are stuff like k-means learnings, hierarchy clusterings, and even something like PCA, principal component analysis. But a combination of supervised and unsupervised learning, it's reinforcement learning. It's actually the closest type of machine learning to how human works. Or like for example, if you have a dog and how you train the dog by reinforce good behaviors, and so the algorithm agent learns by interacting with the environment and getting a positive and negative feedbacks from users. So those kind of program, including Q learnings and like deep adversary networks. So is the statistic analysis the same as machine learning? So we go back to this question. Well, there may be some similarities between supervised learning and statistic analysis. However, most times statistic analysis work with data with underlying probability assumptions, whether it's being normality or equivariances. So it has to be supervised on both input and output end. While machine learning works with disjoint data, which data has been stratified with training and testing. So it doesn't necessarily need to be supervised on the output. Um, depends on the situation here. So that's kind of the highlight the fundamental differences between statistic analysis and the machine learning. Now switch gear to about what is occupational exposure. So, I'm an industrial hygienist, so that's kind of my language to talk about what is industrial hygiene. So industrial hygiene, it's all about anticipating, recognizing, evaluating, and controlling about of occupational exposure. So those common occupational exposure, including chemical, physical, biological, and psychological factors. There's the problem with industrial hygiene these days is we always hear a lot of emergent issues, whether it's being like plastic, wildfire, black carbon, all those sort of things. And we also dealing with all the problems that remains unsolved for decades, like respirable crystalline silica, welding fume, lead, asbestos. So there's a tons of variety of problems. However, there's a very limited resources. I'm talking about both human resources and time and money resources to solve all those issues. So this is create a perfect platform for AI to come in and at least help those problems, solving those problems. And there's also something that AI can help is to fill the gap of the traditional industrial hygiene approach. Um, as a traditional industrial hygiene hierarchy, we often do sampling and we monitor work environment. We compare them with occupational standards or recommendations. And if they're not in compliance, we action like whether implement engineering controls or other kind of remediation such as PPEs. So there's a lot of there's this hierarchy has worked very well for the majority of time. However, it also has some flaws, such as it's usually retroactive, not proactive, because we often investigate when there is issue already arisen or there's exposure already happened. It's not done in real time, so there's some inefficiency in time, and we also will deal with accuracy issues because sometimes we can only collect a limited amount of data. So AI can definitely bridge this gap by improving the speed of analysis and improving the accuracy, and most importantly, being proactive than retroactive. So both industrial hygiene and AI are about solving problems, and AI it's about solving problems with simulated human intelligence. So there's a lot of buzzwords like has been flying around about AI, and there's people even worry about their jobs will be replaced by AI. But what can AI really do to like at least partially replace humans? So data processing really it's a strong advantage of AI because they can process data in a way that human can never be doing. Decision makings are not necessarily the strong point of AI. Well, it's the high level decisions, but at the individual worker levels, AI can definitely help. There's hazard identifications and which AI can help to be trained to identify potential workplace hazards. At this point, what AI cannot do yet? Well, as I mentioned, AI is designed to replace human brains, but it doesn't necessarily be designed to replace censored and the implementation of controls. So if you ask AI to collecting data without like sensors, it cannot do it. They can do metadata analysis, which is kind of like analyzing data on data. They can physically implement controls, but the most important thing is in the situation of occupational environment, when making a wrong decision will make a difference between being alive and dead, which requires absolute trustworthy. I don't think AI has reaching to that point yet. So we'll start with the first job that AI is great at, which is data processing. So Occupational Explorer is all about data, and data is it's kind of like the backbone of Explorer assessment. Without accurate and relevant data, decisions making about worker safety and risk controls are become very different and sometimes become impractical. So data tells us about when, where, who, and how. It identifies who is exposed, what they're exposed for, how long, and at what concentration. So the quality of the data directly influence the quality of the decision made, and especially about how to control and mitigate those explorers. And data sources, where do we get our data from in the IH application? So a lot of quantitative data come from samplers, sensors, and historical and current data. Well, a lot of qualitative data come from feedbacks and just purely observations. In machine learnings, we often talk about the characteristic of data and divide them into three categories: structural data, unstructured data, and semi-structured data. So structural data is it's kind of like data has been fit into predefined formats. Those examples like air quality data that has tracking like particle concentrations, and they have been properly time-stamped and categorized. Unstructured data, on the other hand, they don't necessarily follow a specific format, and a lot of times they don't even being time-stamped. So those kind of like videos and pictures and audio files. In between them, there's semi-structured data, which are data that can be used for further analysis, like logs or even emails that including text and that has been time spent and metadata as well. So the challenge to Occupational Explorer data are the quality of them. So a lot of data come from merged sources, and they're not necessarily inconsistent on what the information has been captured, and a lot of them are also prone to human errors. Also, these concepts come from the 3 V's of big data: the volume, variety, of velocity. So by these definitions, data can be divided into like high volume, high quality, and high volume, low quality, and low volume, high quality, and as well as the worst combination, which is the low volume and low quality data. And AI has a solution for each combination of this. Before AI can process data, there are several steps it has to undertaken. The first one is data cleaning. So a lot of times, because the quality of data, we're dealing with noisy data, stuff like there's outliers, incomplete data, missing sensor readings, and redundant data, duplicate data, and like I said, inconsistent data formats. Clean data or data cleaning is important to ensure AI can perform fairly accurate and produce reliable results. And poor quality data can definitely causing errors in prediction models and decision-making tools. Data cleaning is kind of focusing on removing inaccurate data, while on the other hand, we also heard this term called data wrangling. It's focused on transforming the data's format, typically done by converting raw data into another format more suitable for use. So machine learning or AI in general can be used for complicated missing data imputations. So the traditional way to imputate data is just using simple means, while AI can use to predict missing values based on patterns in the existing data. For example, if there is a sensor malfunction in certain air quality readings, AI can predict by using the surrounding readings and historical data trends. It can also be used to detect outliers and validate the data. and transform the scale. Data splitting is the other one that's very important to develop any machine learning models. Data splitting is basically partitioning of data into training and validation and testing sets. The training sets are used to train the machine learning model, which is the core data set of what the model learns. When we say machine learning, it has to learn to understand patterns and relationships. Validation set, it's a subset of training set that evaluate the model's performance, help adjusting the hyper parameters and prevent overfittings, which we'll talk about later. Testing sets, it's a real world data that's provide a fair evaluation of the model's performance. And those testing set has to be unseen data for training, not being used for training. They are very crucial for assessing the model's ability to generalize. There's typically the common percentage between training data, validation data, and the testing data are divided between majority of it being training data, while the rest divided between validation and the testing data. And there's different ways to splitting data. There's a random, there's a stratified, and then there's time series splitting, and as well as other tools. And future selection is something that it has to be balanced, that if we have too much futures, it can slow down the training process and even making it inaccurate. This is kind of similar to what overfitting will done to models. For example, if we have workers explore data in this format, definitely we're interested in like data time, location, and what concentration of explorer is. However, does worker's name matters? Despite the privacy issues, but AI actually can study something with worker's name. For example, they will come to a conclusion that workers with a last name start with C will have higher concentration, which is completely false and something that is not even useful. So in the future selection, we will definitely remove worker's name from this process, not only for privacy, but also for prevent overfitting in this scenario. We'll have only relevant data and no noise data by doing future selection. So in occupational exposure assessment, on all the stakeholders, for example, from workers to practitioners to researchers, we all have different needs of quality of data. Because the quality data come at a cost, when we are pursuing high quality of data, it usually driving up the cost of the acquired data. For example, in researchers, if you are aiming to conduct a cutting edge state-of-art research, you definitely want the highest quality of data as much as possible. For practitioner and workers, sometimes you only require a data that's enough for you to get warned or being aware of the environment and exposure. So in this time, you don't necessarily require the highest quality of data. However, you do need a large volume of data to actually fairly accurately predict that. So in this case, we can divide occupational exposure data scenarios into two scenarios. One is a data-rich scenario, similar to what big data has. You can have, in the data-rich scenarios, you will have large amount of data that are either collected or generated for analysis. The data will come with diverse and multiple sources, providing a very wide range of perspectives and insights. The data is usually typically well structured and reliable and comprehensive. So those high quality and high volume data are the best scenario which it can be used to apply sophisticated data analysis technique, stuff like deep learning and predictive analytics. On the other hand, if you only have poor quality but high volume data, it still can be used because those data can be cleaned or learned by just machine learning. In this case, a lot of times IH data can fall into this category, which is a poor quality, which traditional data processing deal with poor quality data is really labor intensive, where machine learning can excel in this case. The first one of the example is high quality, high volume data. It's the data-driven microscopes. And these are study done here at Cincinnati. We collect a large amount of images and data generated by automated acquisitions. And those are high quality, high resolution pictures. And we can use AI to conducting high throughput screenings to classify and quantify patterns or anomalies in those microscope images. And just a lot of computational resources available to do this instead of human eyes to kind of count them individually. The next example will be a high volume and somewhat a low quality data. So we have those low cost sensor networks that can continuously provide real-time data. However, the accuracy of those sensors can be questionable because their cost to acquire them it's fairly cheap. By using AI, we can help to enhance the accuracy and as well as this comes through the large amount of data to provide insights on this workplace. Those examples like we can use machine learning to help analyze hazards, hotspots, and levels in the facility that has been implement the sensor networks. Well, the second set of occupational explorer data are data limited scenario. In contrary to big data scenario, those are small amount of available data. Sometimes it's even insufficient for statistic analysis, or they come with very limited data sources, often limited, leading to a narrow view of the scenario. It also could be unstructured and incomplete. It typically traditionally only works with like simpler analytical techniques. But in this case, AI can help, even though you probably cannot use stuff like deep learning because the lack of sufficient data. However, there's transfer learning, which is using a model that's been trained on a large data set, or a instrument has been trained on a large data set to adopt it to in a scenario with less data. There's other ways using combination of prior knowledges, and so that technique can create models that learn from only a few examples. Synthetic data generation, and these are where real data is limited. However, you can create or augment data set with certain limitations, and to create realistic data samples to train more robust models. There's other models as well. Sometimes using simple AI models or traditional statistic methods can be more effective than using machine learning in the data limited scenarios. Examples of using AI in a data limited scenario is stuff like, again, low cost air quality sensor and monitors. They often provide limited as well as poor quality data. And however, we can compare them with lab grade instruments through transfer learnings and correct them with environment parameters such as temperature, humidities, as well as known chemical and physical characteristic of the contaminants. So more so to a supervised machine learning. Another example is image augmentation. Image augmentation is a kind of a AI assisted augmenting data and to expanding a data set by creating modified version of existing images. This has helped to kind of improve the robustness and performance of image recognition models, in particular how machine learning to recognize hazards. So here's a specific type of data augmentation called generative adversary networks, or GAN. It works by rotating, scaling, flipping, cropping, and adjusting the color, as well as artificially inject noise to pictures to help create images and videos for model trainings. Data augmentation really are great in terms of being cost effective and can improve models, the robustness of models in a way that doesn't necessarily requires additional data collection efforts. So finally, when you develop or adapt the AI model, how do we evaluate? How do we know how well is the model doing? And do we need to train the models with more data, or do we need to including more features? So there's ways that we can evaluate AI and or machine learning models by using them on testing data, not training data, because using them again on training data can definitely lead into scenarios like overfitting. If your outcomes are classifications, for example, like yes or no, or true or positive or negative, you can do so by create a classification matrix, like by classify the true negatives and false negatives, as well as true positive and false positives. If the classification including multi-classes, you can also do this thing called a confusion matrix. And in the binary outcome classifications, you can actually calculate the accuracy by just using true positive plus true negatives divided by the whole scenarios. And you can also doing precisions, which is using true. For example, you are looking for positives, you can using true positive divided by true positive plus false negatives. However, it's important to note that sometimes the precision is not the only thing you presume or accuracy. For example, if there is, let's say, 100 people, if there's a carcinogenic compounds, or there's in 100 people, there's one person can get cancer, and if you are chasing precisions, you can actually ignore that one person to conclude that there's no cancer risk. So that's where, even though there's a small amount, even though it looks like an outlier, you have to do this with very cautious. So that's the third concept, recall, come in. And recall is using to compare the left part, the part that's being left out for when discussing precision and accuracy, to make sure that it doesn't overlook the small amount of data or the occurrences. For continuous metrics evaluation, it's more like traditional regression metrics, such as variances and R-square or mean square error. It's kind of important to to process with data with high biases, because overfitting can happen with models with data with high biases. Well, underfitting tend to happen if there is if you train a model without presenting all the data or even all the informations. If you know that you present all the data, however, still showing underfitting, it's likely that you are not using enough features. So remember, we talked about feature selections. If you do too much features as well as too much variances of the data, you can have something like overfitting, which the model itself can predict accurately inside of the training data. It cannot extend those general predictives to testing data. So moving on to the next task that AI can work for industrial hygiene, it's hazard identification. So traditionally, with all the hazards existing in the workplace, monitor and identify hazards by human, it's sort of a labor intensive, because there are you are using more time of people that they can be more productive on other things. It also prone to human oversight. For example, there's humans can make mistakes and can miss critical issues, and humans also has knowledge gaps, and sometimes they can have limited experiences or expertise. Sometimes they can experience fatigues in doing oversight. Most importantly, but hazard identification by humans is oftentimes retroactive or reactive. Only after the hazard has already been causing damage or injuries, making it very difficult to prevent accidents. And all those things that can be potentially solved by AI, it's doing AI hazard identification, is detecting hazards by analyzing data from images and videos and the other media capture, like for example from cameras, as well as real-time reading from sensors. So the benefits of using AI to identify hazards, including being a proactive approach, has a great improved efficiency and at least being cost effective in the long run. So initially, you may have a higher capital cost of investing in AI. and it can be as accurate as the training data to be, and it will never have fatigues or the common human errors. And it also can be linked to automated control actions or risk management strategies, including like triggering alarms to warn workers. So how come the most common available tools these days are identify hazards in the pictures, whether being a stationary picture or moving pictures. So the way to do it is to taking large amount of pictures and label the pictures with potential hazards and using a pre-trained model or a custom model that's to detect the pictures. The pre-trained models, including some open source models as well as some commercially available website. The custom models can be something like PyTorch or ResNet, or those software packages that can be either locally trained or cloud-based trained. To identify hazards in a picture, typically the computer requires a lot of trainings, and from the least to most, the easiest one to identify is PPE. So if the person wear PPEs or not. Physical hazards or near-miss accidents tend to be easier than chemical hazards. And for biological hazards to be just detected from a picture is pretty difficult because a lot of them are not necessarily presented in a visible way. So here are some examples of using AI to identify hazards. All those are like commercially available. They can use to recognize ergonomic issues. They basically skeletonize the human postures and try to identify if there's any overextending, or is there any other factors. They can also use to recognize the lack of PPE or the inappropriate use of PPE in conjunction with ergonomic issues here in the right hand. We can also apply AI algorithm to sensors. This is kind of an instrument we develop that's using sensors to detect and analyze PPE, personal protection equipment leakages in real time. It's geared to design for respirators. However, it can also be adapted to other PPEs. So in this machines that we're using AI or machine learning approach to provide immediate feedbacks and warnings to prevent either overexposure or leakage of respirators for workers. So it had a very simple user interface here that most workers can get to it. So I would say this is kind of a pretty good way for worker to be aware of their environment as well as the performance of their PPEs. So like I said, there's multiple types of tools that can be available for hazards identification. There's commercially available websites, tools and toolkits, and there's cloud-based open source APIs. And Google have it, OpenAI have it, Meta AI also have it. There's local classifier, which is only recommended if you have resources that to hold the calculations and computations required for those trainings. But if you do, there's a ResNet. It's a software package with PyTorch that can be integrated into any kind of tasks that can train imaging recognitions. There's also other hazards identifications deal with audio and the text. So those are also available. So how does AI help making decision making? So there are two type of decision making. There are high level decision makings usually done on the organization level, which they already talk about identify hazards and implement engineering controls. But the most important features of those are predictive analytics and help develop strategies in the organization. AI really revolutionized it's at the individual decision makings. So there's a lot of people, or they don't necessarily has access to knowledges as well as data as the big corporations or organizations, and those are vulnerable populations and small to medium businesses. So generative AI actually works very well in this way to distribute knowledge and outreach to those specific subsets of populations and businesses. It is important to understand that AI at this stage is to enhance human decisions or enhance decision-making process. It doesn't come to the point to replace entirely with human decision with AI, because there are issues with trust, as well as the one is providing false negatives, and once that will create the safety issues. And AI's dependency on data quality really just tells you that AIs can be as good as the training data you feed to them. However, AI has been pretty good at the supporting decision, or we call it decision supporting systems, or DSS, using predictive modelings and using historical data and algorithm to kind of simulate different scenarios and predict outcomes. Analyze large amount of data in real time or near real time to allow for just real-time feedbacks, and it also can help improving process by predict the best process in the industrial setup, and suggesting engineering controls and other mitigation techniques. So the final part of how AI can be applied to industrial hygiene is the generative AI. And it seems we have been dealing with subset a lot here, that AI starting here, and with more time invested, AI become machine learning, and machine learning become deep learning. So generative AI, or generative artificial intelligence, is type of AI that create new content, such as text, images, videos, and even musics. And they're usually powered by large AI models, which can perform a lot of tasks with minimal trainings. So generative AI works by learning the patterns and structure of existing training data, and then generating new data with similar characteristic. The key point here is the training data. For example, a lot of people using ChatGPTs, and knowing that regardless if you are using ChatGPT 3.5 or 4.0, they are using data that's not concurrent. They are using data prior to I think it's 2021. So they may not incorporating things that are new. Generative AI can help in occupational exposure assessments by interpreting compliance and regulatory standards, writing reports to summarize incidents, and sometimes it can help to outline the brainstorming for question and answers. It can also be used to responding to questions related to occupational exposures, especially for people that doesn't necessarily have the knowledge. So inside generative AI, there's large language models, which is come from another non-machine learning process called the natural learning processing. It is a branch of AI, but it has a little bit overlap with machine learning, but it really helps to for the computer to understand, interpret, and respond to human language in a very meaningful way. So those non-machine learning natural language processing stuff, including Siri. When you say, hey Siri, they don't really go to a data processing or even some sort of machine learning. They just respond to you. They try to understand what you're saying, and they respond to you by search in a pre-existing database. However, large language models are a very specific type of natural language processing that really excels at analyzing language, and particularly generating languages. So there are the broad LLMs. Of course, people have been talking about ChatGPT, and there's other tools by other companies. However, those are less useful in occupational exposure assessment. Most of the time, we're looking at the narrow and targeted applications of LLMs. Stuff like developing a chatbot for industrial hygiene only with curated and limited data sets. So the way to develop those specific LLMs, there's several ways to do that. You can build from scratch, which requires intensive computational resources. You can build them with API, which you can just, and there's OpenAI, which has pretty good documentations and instructions on how to do it. You can also build with coding using some software packages or program packages. You can also build with no coding, no skills, many of industrial hygienists you can using those commercially available websites, which you basically pay the subscription cost for them to do the most hard part of coding while you do the training part. The world of large language models like ChatGPT is really fascinating, but they're tools. They can be tools that to deal real problems, not just like artificial simulated problems. LLMs has the potential to kind of transform the way to transfer knowledges, and they can break down complex questions to save time. It can also use to create procedures in education materials. However, there's several issues with we have to ensure that to properly use LLMs, there's need to be layers of human supervisions and technical reviews, and there also need to be layers of defined scope of usages so that the trainings are not done on a broad scope range of data. The most concerns come from with generative AIs are usually responses from large language models can be distorted easily because they're only as good as the data sets they have been trained on. And in fact, the most available large language models are optimized to provide most likely responses and not necessarily 100% correct responses. So if we trust large language models to generate the reports, guidances, or even program plans, that can be problematic in a lot of ways. However, those shortcomings of LLMs can likely be improved over time because they will be increasing computational capacities and more and more larger data sets, as well as narrow applications to focus on specific real world scenarios. So a lot of issues with LLMs also kind of share with the broad AI and ethics. So it's not always great idea to implement AI in a very quick fashion. AI relies on large amount of data. So a lot of those data touches personal and sensitive information, and they'll be collected from workers. And they're prone to like unauthorized access or breaches or even misuses. So we have to be very cautious about how to ensure the safety of data. Sometimes AI can be aggressive on breaching copyright and intellectual properties. It also have pretty high risk of giving misinformations from anything from unintentional misinformations to just deep fake informations. Transparency of AI is also a problem when people are over relying on AI and not necessarily carefully incorporate AI to their work practice. Accountability, like who is gonna accountable for AI driven decisions? For example, like if someone AI read a report, who is responsible for that? If a self-driving car crashes, is the driver at the problem or is the car manufacturer the problem? So those are the things that we have to be carefully think about. And then finally, about the ethics, is the AI to displace technological jobs. Are AI here to take jobs from humans, or they're here to help? So I don't have the answer to this, and it's a good question to think about and to conduct studies on in the moving forward with AI evolutions. So AI has inherent biases that can perpetrate biases that present in the training data. Biased AI can result in unequal treatment or protection for either inadequate protection or overprotection for certain group of workers. So we need to carefully curate and review training data to minimize the bias and to make sure the data encompassing the complex and changing worker demographics and ensure that there is unfairness in decision makings and most importantly, regularly monitoring and auditing the AI system and to ensure that any biases that may arise can be addressed. So I will end with this saying, AI should be autonomous, but also ethical to human standards. I guess I can provide some key takeaways here in terms of the talks today is a kind of quick overview of what AI can do in the occupational explorer assessment scenarios. So AI can enhance data collections, cleaning, and pre-processing, and allowing for a faster and accurate explorer assessment. AI can kind of sort of automate hazard identification and ensure regulatory compliance and reducing human errors and increasing speed of assessment. So AI can also help in real-time decision makings by analyzing environment, operational, and explorer data in a way that it's impossible to do it. And they can analyze and giving predictive analytics, and those can help in decision making as well. So AI has to be implemented responsibly, and we have to addressing issues such as data privacy, and biases in data, as well as the impact of like AIs on employment. So the future works of AI should, as the AIs continue evolving, we should integrate AI with more sensors as well as engineering controls defined by industrial hygiene or occupational explorer assessment and control. And AI will, with more capacity, they should be more accurate and capable of predicting personalized explorer and risk, helping or augment human decisions making, but not necessarily replacing human decision making process. And definitely stronger regulations on AI governance frameworks should be developed to protect worker data and ensure fairness in AI-driven decision makings and transparency, so of course. So wrapping up, I'm all about getting folks here in occupational safety and health into the AI conversations. So we have to embracing AI. It's here to stay, and we have to pushing for innovations and up our games in occupational safety and health. I mean, the goal is to get more people, more educators, researchers, and practitioners to see the endless possibilities AI can bring to a table that sparking new ideas and efficiencies. So here, that is my talk today, and I'm happy to answer any questions at this point.
Thank you so much for such an important and informative presentation. That is awesome. At this time, if you have any questions, you can enter them into the Q&A, and we do already have a few questions. Also, for anyone who might have put a question in the chat, if you don't mind pasting it to the Q&A for me, that'll just help me keep track of them better, make sure that your questions don't get lost in the comments. The first question, are you aware of any case studies on industries that have already started using AI for hazard identification?
I'm aware there's many industries already using it. In fact, in Cincinnati, in the areas of Cincinnati, both GE, General Electric, and Procter & Gamble has been using AIs to detect hazards in the workplace. This April, I attended a seminar offered by University of Illinois Chicago ERC, and during that I chatted with several industry people, and they also kind of introduce AIs and they in their workplace, and some of them are shown here in some of the examples of hazards identification. Yes, it has been implemented, and there's problems arise from that, including privacy and the cooperations of workers with AI systems as well.
Thank you. Well, this actually highlights one of the issues you mentioned, but their question is in the context of cybersecurity. Is it advisable to switch everything on AI? Is this too exposed in industrial settings? They process safety sensors, which can monitor and be regulated either manually or electronically. So what would be your thoughts around cybersecurity and switching systems to AI monitoring?
Yeah, that's a great question. In fact, that's probably $1 million question about data security. And the thing I can say without unwrapping too much into this, it's AI is here to stay. So we have to embrace it instead of guarding AI away from data we have, because the more data AI can be trained on, the more accurate and fair decisions can result from AI. However, yes, and as the world going on today, there's concerns about data breaching and security of privacy data, or or workers' data. So it has to be kind of cautious. And I think ultimately there's also possibility of local trained AI that isolate the data sets from cloud-based AI. That also can be an option if your data is really sensitive or requires the highest level of security. But yeah, this is, like I said, it's $1 million question that requires a lot of a lot of thinking, a lot of thoughts and safeguards about data.
Thank you. And to comment, great presentation. Do you consider or do you think that AI will contribute significantly to the improvement of professional judgment?
Yes, because like I said, AI is nothing new. In fact, there's many things that we have been doing for years in decision makings can be classified as AI by today's standards. Stuff like Bayesian decision makings and those are like one of the comments here in the chat box. It's AIHA has a great resources for this. Bayesian decision makings has been here for a long time, and they are classified as a part of AI as well. So yes, yeah, it definitely can be used in that way. And it's there's new approach and there's old approach as well. And the only differences these days are we have a large computational capacity as well as more training data. That's the only differences. But they're here, they were here a long time ago even.
Thank you. And we have one more question that we'll get to today. So thank you to everybody who put your questions in. When quantitative risk assessment models came into widespread use, a skeptic compared them to a captured spy, tortured enough, and it'll say anything. On the other hand, when PIMEX/VEM was introduced to industrial hygiene, it was hailed for transparency and intuitive appeal to workers. Do you think AI will push the field more in the direction of complexity and opacity to lay people? Or how can we help it make the results of IH evaluations more comprehensible and actionable for exposed workers?
Yeah, I think that's a great question because we want to solve the transparency issues with AI as well as make AI available for everyday workers for the broad community of workers. And I think with my prediction or my I don't have a magic ball, but AI will push the field more towards make it results of IH evaluation comprehensible to exposed workers because the availability of the knowledges as well as the data sets that's available for training those AI models. However, it's also another thing is for regular workers, they don't necessarily have the technical ability to review those or audit those knowledges. Means that if risk assessment or using AI to push information to the workers, they don't necessarily have the ability to identify whether that's truthful information or not. So those are the part that has to be careful that there has to have some sort of safeguard. If someone goes on ChatGPT and asking questions like, am I going to be overexposed? And ChatGPT can give answers based on the data sets it has been trained on, but not necessarily truthful results. So it's all about the oversight, like one of my slides says, human oversight of those processes. But I don't think AI is going to pushing towards more complex and opacity. I think with the evolution, AI will just be more available.
Well, thank you so much for your presentation and your answers to our questions today. In closing, are there any additional resources or trainings that you'd like to point folks to? Where would someone who is just getting started turn to get some more information on this?
No, I think it's great that we already initiate a conversation. Everyone will spend their 1 hour time here with me to think about how AI can change their workplace practices. The best part about AI is you can learn AI with AI. So you can go to places like if you can even ask ChatGPT to like how can I learn more about AI, and they will give you answers not necessarily 100% correct, but it will give you a starting point to you can do your research.
I love that answer. Use AI to learn AI. Teach me about you. Well, thank you so much, Dr. Wang, for being here today and for your amazing presentation. Thank you to everyone who joined us. We appreciate you being here. Be sure to check out our website for other upcoming webinars. We'll be joined by the University of Cincinnati again later this month. And you can find us online at coeh@berkeley.edu/about-CE. Thank you again, everyone, and I hope you enjoy the rest of your day.
Thank you. Bye.